tutorial on creating a basic tokenizer in Rust. So what this tokenizer basically does is it converts of my own custom programming language that I'm working on, which is a forth-based language. So it converts a file of that language into a series of tokens that can then be perhaps translated into assembly language or whatever basic language you want to do or whatever you want to do with that tokens. But it's a crucial part in creating a language is creating a tokenizer. So this is a pretty simple tokenizer for now, and I don't know if it's written the best as I'm pretty new to Rust and I'm new to creating languages. I also don't know if I'm going to have a series on this or whether this is just going to be a one-off tutorial, but anyways, here we go. So we have our file that we're going to sort of convert into a series of tokens here. So this is a fourth language I'm creating, as I mentioned earlier, and which is why also the syntax might seem a bit weird. It's not too similar to C-based languages because of its stack-based nature, so it does look a bit odd, but essentially all I'm doing here is, first of all, I'm creating a function on this line, so def hello world, and now inside that function I have all of this. The end marks the end of the function, obviously, and inside the function, so when this function is called or subroutine is called, it runs the add operator, it adds 20 onto the stack, runs the divide by operator, and then there's also an if condition, so it has the if condition, and inside the if condition, so if the top value on the stack is true, then it runs all of this, which is just adding hello there onto the stack, and then running the print command, and then exiting the if condition, and then exiting the function, and finally in the main part that's actually run, I call the hello world function, I add 1 onto the stack, I add 2 onto the stack, and then I run that addition command. Now it is obviously, a tokenizer doesn't actually convert this language into some sort of other language that can be runnable. But instead, it just converts into a series of tokens that are much easier to work with when creating that actual conversion code. Okay, so let me quickly run my tokenizer to show that it works. I'm going to do cargo run, and here we go. Let me quickly resize this. Okay, so over here, so all I have is sort of like a print tokens function. So it stores it in this custom data type I created called token, and it stores it as a list of different tokens. And I have also a separate function that converts, that allows you to print out a token and show its string representation of what that token means, which is what I'm running for all the tokens so that we can actually see what it does. Okay, so first of all, I have the function hello world defined. So there's a function hello world defined, and inside that function I have all of these tokens. So the less than marks the start of the function, and then the end func greater than symbol marks the end of that function. So inside that function I have the different tokens, the add token, right, as this one is there, the add token, the number 20 token, the divided by token, and then I have an if condition. So I have an if token, and inside that if token I have the string hello there, and then the print operator, and then that if condition is the end of that if condition, and so on. And then at the very end I call the function hello world, which I've previously defined. I have the number 1 token, the number 2 token, shown here and here, and then the add operator. So clearly my program does properly tokenize this chunk of code. So how does my tokenizer work? Well, let's look at it. Okay, so let me open my Rust file and let's go through it. So I don't have any other real imports other than some standard 2 imports that allows me to do standard procedures and to go through a file. So I have my file path first, which is my main.forth file, so on. Now here I go through, I have my enum token. This is my custom data type that goes through the different types of tokens I have. So I have the divide operator token, the add operator token, the subtract token, and these four tokens, should I say, don't really require any. Sorry, these four tokens don't require any arguments because other than being add, dividing, subtracting, or print, they don't really have any more substance in them, if that makes sense. However, the function token, the function requires a string, which is the name of the function. So that's one of the arguments for the token. And then an actual vector of different tokens inside that function. So those represent all the tokens that are ran when the function is called. Now, this might seem a bit confusing, but here is the structure I'm following. So go here. So let's say I have my program here, right, represented by the square. Inside that square, I might have, let's say, print statements here, right? Print statements, print statements. But I want a function that has that can print out, let's say, add two numbers and print it out. So inside that, I have another list of tokens. So function hello, and inside this function, I have another list of different operations and things inside them. So 20, and then a print token. So for this reason, my function hello over here has sort of has a list of tokens inside of it that it runs. So I have my main list of different tokens, and then inside that I have a function such as the hello function, or different sort of blocks, you can say, that have its own list of tokens. And then later I can call the hello function, which goes through this, and so I can call the hello function, which is done by the call function token, which goes through hello and then runs these tokens. It goes through these tokens. So this is why I have some sort of tokens which have a list of tokens as an argument. It's the same case with an if condition. The if condition, if true, or if it actually decides to go through, has a list of tokens inside that block that are ran whether it's true or not. And then I have an end token representing the end of either an if function, an if condition, or a function token. And finally, I have the call function token, which has a string as an argument because it requires the name of the function. So, oh, I forgot to go through this. I have also a number token, which has an I32 for now, which is the data type I'm going as the different types of numbers, and a string token, which obviously has a string as an argument. Alright, so let's go through it. First of all, I have a reader. So I have a class or a struct in Rust called a reader. Now, what this reader does is it basically goes through my code one character at a time. So when you're creating the reader, you give it the path to the code you want it to read through. So it first of all opens that path, and adds it all to a string, right? So the file.read2string data, and then it creates an instance of itself where it has three values that it stores. Its current position, so its current position in the codes, because the reader goes through the code one by one. The position starts at the first character, 0, and then it keeps incrementing itself as it's called, and it gets incremented by the next function. So the position is added by 1, and then the second important function is the peak function. All this function does is it looks at the current it gets the current character at the current position. So it checks. So how do I explain it? Okay, so as the position gets incremented, to look at the character at the current position, you call the peak function of the reader. And then it has a few other functions that can help me out, such as is whitespace, which just uses this peak function and checks whether my the current character it's on is a whitespace. If so, it returns true, otherwise it returns false. And the last function, which is function at end, which just checks if this current position is greater than or equals to the length of the data. If it is, it returns true, otherwise it returns false. Okay, this was the function I was earlier talking about at the start, which is just my method of printing out the tokens. So over here I obviously have token, so all the different types of tokens and the corresponding thing it prints for them. So for a token that is of the number type, it prints number and then the number. If it's asked to print the token of a string type, print string and then the string, and so on. So this is just how I convert the vector of the list of tokens into something that can actually be printed, so I can see that everything's working. And now for the main part, the actual tokenizer. So the tokenizer has two variables that it uses. First of all, it has the reader. So the tokenizer uses a reader to increment through the characters in the file that it's translating and accordingly create a list of tokens. It also has another another variable, which are the different functions that have been defined. We'll see why this is important a bit later on. So first of all, there's the new tokenizer, which just creates itself with the current things. There's nothing much to that. But here is the main thing, the function get tokens. So let's see what this is all about. So this function get tokens is basically the way of feeding in so after you create a tokenizer, let me go through my very end. After you create a tokenizer, you run tokenizer.get tokens, and yeah, so it gets the tokens from a certain file, and it does that. So you obviously first you have to create a tokenizer by passing in its file path, and then get tokens basically gets a list of all the tokens that it reads from that file that it translates. So that is this get tokens function is sort of the main essence of this code essentially. So first of all, obviously it creates a list of tokens that represents the tokens that it returns, and now it keeps incrementing the the reader. So the reader keeps incrementing by 1. So while it's not at end, it keeps going next over here. So it keeps increasing by 1 character, and then it examines the current character to sort of see what it is. So first of all, if the current character is a number, so if it's a digit, so if it's 0 or if it's less than or equals to 9, then that must mean that it is currently on a number. And what it does is it does tokens.push self.read number. Now what does that mean? So it basically adds a token, right? So it adds a token, tokens.push, and then self.read number, which basically means, because I have a function, so self.read number. Let me go to the definition of this function to show you self.read number. Yeah, so I have a function called read number that when called, it creates basically a number. So let number equals string new, and then it just keeps incrementing the reader until it reaches the end of the number. So it keeps incrementing the reader until it reaches the end of the number, right? So it keeps incrementing it, and then it keeps adding on to this buffer for the number. So it keeps adding on to that, and then ends up returning, once it reaches the end of the number, it returns a number, and that's parsed into an integer. So it returns the token number, and it's just parsed into an i32. So it returns the token of the number it was currently on. So to reiterate, this just means once there's a digit detected. So if it detects a digit, that must mean it's on a number. So then all it does is it goes through, it keeps going, the reader keeps reading until there's it keeps reading until there's no more digits. So it keeps reading as there are more and more digits, and it keeps adding onto this buffer, and then that buffer is then returned as that buffer is converted into a number and returned as a token, which is then added on to this tokens list. And now going on to the next part, it's if there's a quotation mark, then you just do tokens.push self.readString. Now this works very similarly to the read number function. However, it's the same for a string. So let me go to the definition of read string. Okay, so here it is. So it keeps going through the next, so it has a buffer. So string is the buffer, this variable is the buffer, and it just essentially keeps going to the next character until it reaches the another set of quotation marks, which marks the end of the string. Until it does, it keeps adding the current character, the current peak of the reader onto the buffer, and then eventually once it reaches the end quotation mark, you can know that the string has ended, and it returns the token string of the buffer it's gone through. Okay, let me go back here. So that's what to do if it detects a quotation mark. And now there are a few of the simple one character operators. So if the current character is a slash, then tokens, then add the divide operator, add the subtract operator, add the add operator, so on. If there's a white space, just do nothing because there's no, it doesn't really, white spaces are mainly ignored. If it's none of these, then it has let toke equals to self dot get command. Now, what does that mean, right? So this is another function. So let me go here. Where's get command? Oh, let me go definition. Okay, this is quite a hefty function. Now, all this does is it returns a token if everything was valid. Now, this is if it was not any of the previous things. So if it wasn't any one character operator, or if it wasn't like a number or string or data type. Now, it basically gets the next word as a whole, because it's very convenient in Forth that each operator can't be any longer than a word. So it might be print, for example, the next word, and that's another thing to do. So it gets the next word, and if let's say the next word is print, then it simply returns the token print. And oh, I should quickly also mention what this get next word function is. All this does is it returns a string of the next word present in the reader, by the reader. So it just increments the reader by one until it reaches a white space, and then keeps adding on the characters onto a buffer, and then returns that buffer. So if the next word is print, then it simply returns a token print. If the next word is an if condition, so if the next word is if, that means we're at the beginning of an if condition. And now, remember as we mentioned earlier, an if condition is a separate block of code, right? So you have an if condition, and then inside this block, you have some separate operators, some separate tokens that might or might not be ran. So inside this if condition, if it sort of runs self.getTokens on itself until it reaches an end block. So it runs self.getTokens. However, a thing I did not mention earlier is, let me go to the definition of self.getToken, this boolean end. This indicates whether the self.getTokens, this function, should look out for an end statement. And if it does, so if it does look out for an end statement, and it encounters an end statement, then it simply returns the tokens it's detected up until then. So this means that when I run this, when it encounters this if statement, it runs self.getTokens onto the current code again. So it reruns that code and keeps getting tokens up until, so one second, I'm sorry, this is hard to formulate, but once it encounters that if condition, it runs self.getTokens, and then um, it gets all the tokens until there's an end block, and puts those tokens that it's detected until that there's an end block into the if condition. So remember, if we go back here, an if requires a vector of tokens as an argument. Those are the list of tokens that are inside the if condition, right? So if we go back here, it's an if condition. So it goes through that self.get tokens, and then it returns. Then if that's the case, then it adds on that. So then it adds on a token. So it returns okay to token if, with the list of tokens being the self.get tokens up until an end block. So it gets all the tokens up until the next end block in my code. So up until the next end is called, and adds them onto the list of the if token. So this can create sort of a nested structure where my program has an if token, and inside that if token, inside one of its parameters, it contains a list of another list of tokens with all of the things that should be run if that if condition is true. So that's what that does. The end returns the token end, and define has a very similar thing, where so first of all it gets the name of the function. So let name equals self.get next word, so it gets the next word, and then it does the same thing as the if condition, where it gets the next it runs self.get tokens true, meaning that it should scan for an end statement. So until the next end statement, it keeps adding tokens to the function parameter token. So all that means is the function has a list. So a function has, first of all, obviously the name, so which is defined here, the name, and then the list of tokens that are inside the function, right? So it gets that by looking at all of the tokens up until, so by running self.get tokens up until it encounters an end block. Okay, and I also have this error checking, so that if there are any errors, such as, let's say, the integer could not properly be unpacked or whatever, it does just it returns an error result, which is why I have like this result clause. And that's essentially it. So that's how it gets commands, and then it gets different tokens, and it creates this way of also being able to create. It allows for FS. It allows for sort of nested things where I can have a function of hello world, and then inside that function I can have a separate if statement, and if I want inside this if statement I can have something. I can have yet another if statement, and my program understands sort of all of these different levels, and how this hello world function is its own token, and inside that token it has all of the different tokens inside of it, and then it has that one of the tokens inside of it is this if condition, and that if condition has a list of tokens as one of its parameters, which has all of these, and then it has an if statement inside that. So it creates this sort of nested loop of tokens that helps you sort of helps you create these different levels, sort of shown here. Yeah, that's about it for a tokenizer made in Rust. So I'm gonna have the code down in the description, and yep, that's about it. I might decide to make this a series, or let me know. And I'm sorry if my explaining wasn't the best. I'm not really the best at this. However, I do hope you've at least learned something in this video. Thank you.